We are back and still talking about the periodic table. Before we move into the organization of the periodic table, let's remind ourselves about the skills that we learned in the last lesson. So the number of protons, electrons, and neutrons based on the information on the periodic table. So find the element zinc. How many protons would it have? Well, it's going to have 30 because that's the atomic number. How many electrons is it going to have? Well, that's also going to be 30 because remember, for every positive proton, there's a negative electron canceling it out. Then we need to figure out neutrons. That's where we're doing subtraction. So zinc's atomic mass is 65.39. I'm going to round that down to 65, and then I'm going to do 65 minus 30 to get a total of 35 neutrons. Just wanted to make sure we remember all those skills before we move into the periodic table as a whole, which is where we're headed today. So the periodic table, remember, is organized by atomic numbers because that is the most important thing about an element is how many protons it has, because that's what makes one element different from another. One important place on the periodic table that we need to talk about is the stair-step line. Now, most periodic tables that I Googled have the stair-step line on there. If not, try to find a different one because you're going to want to know where that stair-step line is pretty much at all times. So it's a line that looks like a set of stairs that separates your metals on the left from your non-metals on the right. And one way that students remember that is that M comes before N in the alphabet. So reading left to right, you have your M metals and then your N non-metals on the right. The periodic table is called that because it periodically repeats itself. So periods are actually the horizontal rows on the periodic table, the picture on the left. And then on the right, those vertical columns are either going to be called groups or families. Now notice there are several that are colored in, and then there's some that aren't. Those are kind of weirdos. We will mention them briefly, but we're not going to do much with those white areas. So let's talk about the significance of the columns today, because that's really where we're going to focus. So elements come together and bond with each other, which is where we're headed in the future in the next week or so for why things turn into compounds. Like, why is sodium chloride sodium chloride? Why does that sodium and chlorine bond together? Well, it has to do with special electrons in the atom called valence electrons. And they are the ones found on the outside ring of that element. Well, how am I supposed to know how many valence electrons something has? The good news is that is the significance of the columns. That's why certain elements are in certain columns. So when I need to know how many valence electrons an element has, I just go to the periodic table, I find what column it's in, and then that's how many it has. So notice, remember I said we're not going to do much with that middle section. So when we're counting, we're going to do column 1, column 2, we're going to skip all that middle junk. Column 3, 4, 5, 6, 7, and 8. Now, on some periodic tables, you may see those last ones as like 13, 14, 15. We're going to call them 3, 4, 5, 6, 7, and 8. So, anytime that I ask you, hey, how many valence electrons does this thing have? You are always going to tell me a number between 1 and 8. You will never tell me a number bigger than 8 for the total number of valence electrons. Remember, we're not doing electrons today. We're doing valence electrons specifically. So like I said, we can do it by looking at its column. And I love this picture because it doesn't even worry about the transitions. So you can see everybody in the first column is going to have 1 valence electron. Everybody in the second column is going to have 2, and on and on and on. Do you see a weirdo anywhere? Look again. What's up with that one? So that is the element helium. And it's hanging out with the 8s, but it has a number 2. It's pretty weird. So let's look at helium's information. Well, it's atomic number 2. It has an atomic mass of 4. So In our last lesson, we talked about how many protons it has. Well, that would be 2, because that's its atomic number. And how many electrons does it have? Well, it has 2, because remember, that's the same as your protons. So if it only has 2 electrons, then it can't have 8 valence electrons. That doesn't make sense. So even though it's hanging out with the 8s, it only has 2 valence electrons. Remember that one. It's a tricky one. So the other important piece of information that comes from our columns are family characteristics. So they are actually put in columns because they have a lot of things in common. Obviously, they have number of valence electrons in common, but they have some other stuff as well, which we'll talk about in our next lesson. So Miss Doyle, another Leesville teacher years ago, said that she came up with this little saying to help her remember which ones are called families. She said, "I column my family." So hopefully that helps you out. So here is the list of the names of the families. Now, like I said, we will talk about them in the next lesson, but I thought it'd be good to have just one slide where you could pause at any point that you needed to and have all of them listed there. So let's practice what we've learned today. So first of all, find the element nitrogen. Now, I don't have the whole periodic table there, so I do have the column numbers up above it. So what column is it in? It's in the 5th one, right? So how many valence electrons does it have? It has 5, because remember, that's the significance of the column. So what are 2 other elements in the same family as nitrogen? Well, families are our vertical column. So in this particular picture, you should have chosen phosphorus and arsenic. So families, remember, are your vertical columns. So how many valence electrons does phosphorus and arsenic have? Well, they have 5 as well, right? Because they're in the 5th column as well. And then a second ago, I had the different names of the families. Now, not every family is named after an element, but this particular family is. It's called the nitrogen family because nitrogen is the first element in that column. Now that you've got these skills, let's put them to the test.